Mobile phone plays a major role in day-to-day life of every human being. But what about the case of physically challenged people like deaf, blind and dumb? This paper explores the possibility of integrating the applications of STA and speech recognition engine which helps these peoples. The typical cell phone for blind and deaf users shall have the applications like STA, video to speech, camera to record the facial movements of the users. Cell phones of the blind users have the ringing system similar to that of vibration and to indicate a new call. Voice commands to take up the voice recognition to take up the voice commands. Human speech is converted into phonemes and then to visemes. Here and then facial movement analysis part is done. Finally, visual manipulation.
Animation technology. Here we use a camera to capture the lip movement of the blind. Voice signals are converted into phonemes. Phonemes are the individual parts of human speech. Phonemes are converted into visemes. Visemes are the visual representation of phonemes. At the end of this, animated face opens the receiving end of the deaf. The component of lip information which match with the mouth movements with the phonemes of speech. Here we have 4 fiduciary points marked at the diagram. Fiduciary point P1, P2, P3 and P4. Fiduciary points were marked. Speech processing system converts voice into string of phonemes and then to visemes. Computer animation technology gives a visual data which generates immediate frames. This helps to provide smooth animation. Those animation phrases are interrupted by the deaf users by lip reading. Facial movement. For analyzing the facial movement, the speech is divided into 2 main components. Lower lip behavior and upper lip behavior.
As I said earlier, there are 2 types of lip behaviors, that is lower lip and upper lip. The lower lip behavior is due to the voluntary movement of lip tissues which are in the lips, fiduciary point P3 and the movement of TMJ. It's called as thermomandibular joint, which is located at the lower edge of the mouth. It is a place where the upper and lower jaws meet together. Rigid body deformation which occurs around the mouth can be identified, which is used to control the animation of the synthetic face around the mouth. For calculating the TMJ of the lower lip, we use the formula P3 of T minus R3 of T is equal to TMJ. P3 of T is the fiduciary point P3, R3 of T is the rest mood position, P3 of T is the rest position. If we subtract both, we can find the TMJ value. To calculate the distance between P3 and TMJ centers, we use this formula. P3 is the fiduciary point and TMJ is thermomandibular joint. The upper lip movement is same as that of lower lip. The only difference is that the absence of TMJ in upper lip. It is associated with the voluntary movement of lip tissues and fiduciary point P1. As I said before, the only difference between the lower lip and upper lip is that the TMJ is not entangled with the movement of upper lip. Rigid body transformation of the upper lip can be derived from this behavior to control the animation. Viseme representation is the most important part of the project. To represent the movement of mandible in the synthetic face, rigid body transformation which occurs in the mouth and the TMJ are applied to the polygonal vertex of the geometric model. The behavior of the upper and the lower lip are mapped to the synthetic face of the geometric model based on the 2 conditions. Points of the geometric model corresponding to the fiduciary point. Skin tissues around the mouth including lips. Video to speech. This is the reverse process of STA. Video is converted into viseme, that is visual representation of phonemes. The example is given at the below with the geometric models and it's converted into phonemes. The phonemes are the individual parts of human speech and those are clubbed together to give the voice signal.
This is the final stage of our slides. If the blind calls for a deaf or dumb, the ringing or vibration is received at the receiving end. The animated face opens and the lip movements are just runs in the form of synthetic face at the receiving end. If the deaf or dumb users replies for his message by his lip movements, it will be captured and it's converted into phonemes and then to viseme and then it's clubbed together into voice, or it will be converted into text format and will reach the blind. This is the concept that we have extracted from a particular paper. As we are interested in lab view, we have used the same concept in image processing and we have implemented a new project, that is the input image is given by a blind and the input image is processed and it is converted into form of text by comparing the input image with the predefined set of images which are present in the database. The project goes like this. The construction of the project goes like this. Here we have created 3D folders, namely database, capture and main. Capture is a program that is written in order to have the input images and store those images in the database. The database is a folder that is created in order to store the images which are captured in the capture program. And next one is main. Main program is written in order to process the project. First, let me explain the capture program. These are the basic statements, that is CLC, clear all, close all. The input image win video is a command which is used to switch on the webcam of the lab, and set input return color space RGB. In order to convert the image into RGB format, it will pass for 3 seconds and it will entitle the image as input 1, and the image is resized by using the command im resize, and it's resized in the ratio of 200:180. This is done in order to have uniformity. And the old image is deleted by using the command delete input 1, and the directory of the new resized image is changed by using cd, that is change directories of the command, and then the new image is named as 1, 2, 3, 4 or 5 by changing the number here. Now I have placed as 1. This is the complete working of this capture set of program. Next comes the main program. Here also we have the basic commands like CLC, clear all and close all. After that, the input image is received by using the win video command, and return color space, it's converted into RGB image. It will pass for name as input 1, pass for 3 seconds, resize the image in the, to 200:180 ratio, delete the old image and title the image as input image. After that, it will change the directory. Here the process or the complete working of this project is that the input image RGB to gray, that is the input image that has been captured with the help of the program, is converted into grayscale image, and the new image and the old image are subtracted by using I different, that is image difference, that is equal to image new minus image old, and then it is saved in the name of I different. After that, we have programmed in if else format, that is this sum of bandwidth area. It is the command which is used to compare the bandwidth area of the particular image that is present with the grayscale image, and subtract those images and find the area and compare it with the capture database image. If the bandwidth area is equal to or greater than 10,000 to 12,000, the alphabet will be M. If it is between 12,000 to 17,500, it will be A. 22,000 to 30,000, it's E. 17,500 to 22,000, it's I. 14,500 to 70,500, it's U. And then 7,000 to 11,000, it is U. Here on the side of working, we have interfaced MATLAB with LabVIEW. Here the database, now we are going to see how we are storing the images as input to the database. Here this is the capture program that we have written. Here as I said earlier, win video command will switch on the webcam for 3 seconds, as I have given pass for 3 seconds, and will name as input 1, resize the image into 200:180, and then delete the old image and store the input image in the database, that is it will change the directory by using cd command, and it will name it as 1. Now the working goes like this. If we want to see the stored image, we should go for the database. You can see the letter which I have spelled as A. Now let's store 5 more letters, and the second letter is, I'm going to spell E now. is second letter which I have spelled now. Now let's see the third. I have spelled O as third. U as fourth. W as fifth. We have successfully loaded 5 images into the database. Let's see the working of the main program now. This is the main program part, and we have done this by creating a MATLAB script in the database, in the lab view. Let's go to the search MATLAB script. In this we can write the MATLAB coding as such we write in the MATLAB, and then the main disadvantage is that it is case sensitive. Now I have written those coding in this MATLAB script now.
Single run.
We're going to give the input through the main program now. If we run this, okay, now the input image is given. We should stop it, and if we see, this is the input image. I have spelled E. This is the grayscale image that is compared. That is the input image subtracted with the database image. That is the input image, and all the noises are removed here, and this is the database image that I have compared. Now this the specialty of the program is that it will compare the image which is taken in the lab view with the images that are present in the database that we have saved already. See here. Here in the second image I have spelled as E. This image is taken and compared now, and the output of the program can be seen in the command prompt of this. See, the alphabet is E. This is the output of the program. We are very glad to present your project in NI, and thanks for giving this opportunity. Thank you.